professor of Chungbuk National University, Korea, and also moderator of this ICAS 22, the International Conference on the Advancement of STEM's opening ceremony, and also keynote session. Of course, it is very great place for me to be moderator at this ICAS 22. Before we start, I will briefly talk about today's opening ceremony procedures. The first, there will be the opening address by Professor Baek Sung-hae, who is the president of the International Society for the Advancement of STEM Korea. And then there will be a congratulatory address by Chung-won-jo, who is chairperson of Foundation for the Advancement of STEM Korea. Continuously, without interruption, there will be two keynote lectures. One is Dr. Linus Roelofs from Netherlands, and the other is Professor Dong Jiang from Japan. Okay, I think we should begin. I declare the International Conference on the Advanced of STEM 22 open with your big hand gesture. Please show us. Thank you very much. First, there will be opening address by Professor Sung-hae Baek, who is the chairperson of the International Society for the Advancement of STEM Korea. Please give two big hands. Professor Baek, are you ready? Yeah, okay. Professor Baek, we cannot hear your voice. Professor Baek. 백성희 교수님, 들리지 않는데요? 이거 누가 컨트롤 하나요?
안 들리시나요?
네.
잠시만요. Just a moment.
For being here with us.
Yeah, it's okay.
Good morning, afternoon, evening, ladies and gentlemen. Thank you to every one of you for being here with us today. I am truly delighted to be hosting this International Society for the Advancement of STEM, which is already celebrating its 5th conference. The society was created for international academic exchange for the development of convergence education in 2020. The three major visions of this society was flexibility, sustainable communication, and collective intelligence. And the theme of this conference is Convergence STEM Education in the Age of COVID and Beyond. I express my heartfelt thanks to the keynote speakers, world-renowned Dr. Linus Roelofs, and the engineering human resource developer, the Professor Dong Jiang of Yamaguchi University. I hope that you will receive a lot of inspiration for convergence education from the two keynote speakers and many presenters at this conference, and exchange various research results related to convergence education with each other. My special thanks to Professor Mi-hae Kim of Chungbuk National University, who is the head of the Cultural Convergence Center at the National Research Foundation of Korea. She gave a lot of support to this conference. Also, I would like to express my deep gratitude to Dr. Hyun-sik Ju of the Convergence Education Research Institute, Korea National University of Education, for his hard work in organizing and running this conference. In addition, I would like to express my gratitude to those who have worked hard for the society. I will continue to strive for a successful academic operation. I again welcome you to ICAS 2022. Thank you.
Yeah, thank you very much for your warming opening address, Professor Sung-hae Baek. As she mentioned, the flexibility and sustainable communication and collective intelligence are three major visions of this society. And the theme of this conference is convergence education in the age of COVID and beyond. As you know, COVID-19 pandemic has changed the way we live too much, and we have been experiencing a lot of new things. And also COVID-19 pandemic has given us a chance to try new things, like at this conference, ICAS 22 by online. Okay, next, there will be congratulatory address by Professor Chung Won-jo, who is the chairperson of Foundation for the Advancement of STEM Korea. Please give him two big hands. Professor Chung Won-jo, are you ready? Okay.
Very nice to meet you, everybody. I am Professor Cho from Foundation of the Advancement of STEAM in Korea. Very nice to meet you. All the STEAM friends around the world, and Professor Park Sung-hae of the ICAS President, and Ho Gol-bak, Chairman of the Organizing Committee. I thank all of your effort. Last year, as you recall, we together expected the long tunnel of COVID will be ended. In human history, we had already 7 times pandemic. Every time, world community smartly managed hard times together. Even human found big transition momentum during pandemic times. Now, let's meet Isaac Newton, for example. Back in 1666, London lockdown. In that year, 1666, Isaac Newton just graduated from Cambridge. He had also get scholarships to stay at Cambridge for 3 more years. However, due to the shutdown, lockdown London, he went to his mom in the countryside. There, Newton had a free time and made his most powerful insight. That was falling apple. Newton discovered gravity during the pandemic times. Afterwards, Newton's thought becomes even bigger. Now, social distancing is the new norm now, but it's not the first time, as we see from Isaac Newton. People has responded all the time to the threat. We, ICAS, responded to online conference and remote learning are the tools for us. Now, what's the Newton's apple for us? That is the humanity. Today, I'm going to express and emphasize the humanity. We, the creative community, has a responsibility to guide the future generation. Last year, I suggested 5D, five-dimensional education. My foundation is developing 5D frame based upon 4D frame now. The reason is the fifth industrial revolution, fifth IR, is around the corner. The fourth industrial revolution is a lack of the service of humanity. In the fifth, humans and machines will dance together. The fifth industrial revolution will open the way for curiosity, creativity, empathy, and judgment, ensuring a balance between people and technology. I emphasize the humanity for our ICAS in the future. In closing, I recognize your continued effort. Pamela, Carla, Christopher, Farida, George, best friends of ICAS organizing committee, and Rhinus from Netherlands and John Wei from Japan, Lee-Hyun Kim for opening lectures. I now wish all the best and all the success of ICAS 22 today.
Yeah, thank you very much, Professor Zhou, for your delivering an impressive congratulatory address. I sincerely, as he mentioned, he wants to sincerely congratulate you for holding the 2022 ICAS conference. And also, I hope ICAS 22 will come to a successful close. We will now close the opening ceremony. From now, we are going to start the keynote remarks sessions. Okay, let me introduce you to Dr. Linus Ruelopus, who is going to deliver keynote remarks under the title Folding Polyhedra with 90-degree dihedral angle for 20 minutes. Moreover, he will allow us 5 minutes for question and answers after this lecture. At present, Dr. Linus Ruelopus' sculpture, and also you can get the detailed information on him in the PDF files. Okay, let's give two big hands. Okay, Dr. Linus
Yes,
Ruelopus,
hello.
are you ready?
Yeah, can you hear me?
Okay, I can hear you.
I like to share screen. Is it possible?
Yeah, maybe.
Okay. I hope you can see now. My talk will be about Albert Dürer. He was a German artist living about 500 years ago. And what he did, he brought some new ideas about polyhedra, how you can look at polyhedra and how you can make models. And this was the book that he published about 500 years ago. And in that book, you will find drawings of a lot of polyhedra. And this was the first time that nets of polyhedra were published. So another way of making models and another way of looking at polyhedra. And I think the book is very new because there are a lot of new ideas about polyhedra in this book. First of all, it's the first time that unfoldings of polyhedra are shown. But another thing is that the way that Dürer presented the unfoldings together with the picture of the final tetrahedron in this case, you can see that with those two stages, the beginning and the end, he's also told us something about the process of folding. So this may be a first step towards animation even. So suppose we've got an unfolding of a tetrahedron and the tetrahedron, then you can see that the process makes it clear very, very well. And this is the way that Dürer taught us to think about polyhedra. So there are many ways we can now play with the nets of the polyhedra and the polyhedra itself. And that's what I like to do as an artist. So if we go to the book of Dürer, we see the net of the octahedron. And also here he not only showed the net, but also the final octahedron in two drawings at the right. We now know that if you want to unfold the octahedron, there are 11 possibilities to do this, like here. And Dürer just chose one. It's the right in the upper that he took as the unfolding of the octahedron. He might have not known that there are 11, but now we know, and here you can see that it all works. What I said, I like to play with the folding and the unfolding of the polyhedra now. It's a nice way to understand a little bit more about polyhedra and how they are modeled, as you can see here. So a completely new way of looking at polyhedra, not anymore as a solid, but also as a net. Well, the third one I would like to show is the cube. We are now familiar with the cross net of the cube, but also here we have got 11 possibilities. And to show you again that we can indeed unfold the cube in 11 different ways, I made this small movie. And when I look at these 11 possibilities, there are a few that I like the most, and there are the more strip-like polyhedra, like this. So there are four possibilities to put the 6 squares in a strip. In this way, you can fold the cube from a strip of squares. And especially for small animations, this is a nice setup for the cube, as you can see here. So with a little strip of 6 squares, we can make this walking cube. It tells you a lot about how a cube is assembled and well, how you can think about a cube now. So just another one, another example of this. So to teach students about polyhedra, these are very nice examples, I think. Dürer made drawings of all the platonic solids. So you can see the dodecahedron. And again, he did the two stages. So in which he was telling us you can start with just a 2D drawing, but you can fold it into a 3D object. And that process is very important, I think. So we can just make the folding, as you can see here, of the dodecahedron. We can see how the 12 faces come together. And this process between the two stages, the flat and the three-dimensional stage, is, I think, very important. Besides the platonic solids, he also made drawings of the Archimedean polyhedra, and this is also a new step in polyhedra. At that time, when you wanted to make a model of a Archimedean polyhedra, you just cut away some parts of, well, let's say a cube. But in Dürer's way, you don't cut away parts, but you have to add new faces. So in this case, you can start with a dodecahedron to make this solid by cutting off the corners. But in Dürer's way, you have to add triangles. So it's another way of thinking about polyhedra again. So this was Dürer's drawing, and you can see that it now folds into the Archimedean solid. And what you also can see is that Dürer has chosen for a special setup. Well, in fact, there are two halves that he made to set up the plan of the net. And well, again, the halves can be used to explain more about this polyhedron. You now can say that there's a line just in the middle, so you can cut it nicely into two pieces. When we look at Dürer's drawings, we can see that Dürer indeed developed the Archimedean solids by starting with the normal dodecahedron. The two drawings have exactly the same setup. So we can visualize this in this way, that when you start with just a dodecahedron and you make the unfolding, you can then add the triangles in this way. And then make the folding of the Archimedean. So the process is definitely the other way around, not cutting off parts of a polyhedron, but adding new faces. And let's look at a few other ones. The one on the right, we know that's the football. And this is Dürer's net for the football. Again, we can see that it is set up in two halves, connected in the middle with the hexagon. And well, there are many ways to make a net for the football. Well, I will first show you the unfolding. So this is the way Dürer made the unfolding of our football. And I think it's very interesting to think about other possibilities of making this net and change the process, exactly the process of the unfolding. So when we look at the dodecahedron again, an interesting way to make the folding or unfolding is this one. Again, I choose here for a strip, and you see that when you choose for a strip, also the folding becomes more gentle. The process is the interesting part now. So if you do that for the football, then the unfolding becomes something like this, and you see that the folding itself now is a very nice small animation to look at. So explaining something about the structure of the polyhedra, it's my task in this case to make an interesting unfolding. And starting from this, you can explain a lot of things of the polyhedra. What I said, there are a lot of new ideas, not a lot of new things in the writings of Albert Dürer. And one thing that I saw in the drawings of Albert Dürer was also the combination with the tilings. So when we look at this unfolding of the cube octahedron, it's very special because it's in fact part of a tiling. Well, first again, you can start with a cube, and by adding triangles, you can make the cube octahedron, as you see here. So this is a nice connection between the cube octahedron and the cube. But the unfolding pattern is just a part of this Archimedean tiling. And I can show you it in this way. You see that Dürer's net of the cube octahedron is exactly a part of this tiling. And by cutting out part of the tiling now, we have a complete net of the cube octahedron. So again, a new idea, another way of looking at polyhedra, and Dürer made a lot of interesting steps. This was the way that Leonardo da Vinci has made the drawings of the cube octahedron, and in the book of Leonardo da Vinci, we find we find next to the drawing of the cube octahedron also this stellated version of, in which he put pyramids on top of each of the faces of the cube octahedron. So we see triangular pyramids and square pyramids, and also this kind of objects are interesting if you want to try to make an unfolding. First, let's go back to Albert Dürer with his unfolding of this cube octahedron. And we see that in the middle, we can split the polyhedron into pyramids, square, and triangle. It exactly fits. So in fact, this is Leonardo's drawing, but then inside out. And you really fold it the other way around, you will see that we get Leonardo da Vinci's drawing. So a nice way to study the polyhedra. When we look at the octahedron, also this one we can cut out the corners of the polyhedron and then derive a new one. We will this will result in the icosahedron, as you can see here. So again, by adding triangles instead of cutting out parts, we can come to new polyhedra. And in this case, you can make a range of 4 different polyhedra. So making use of the Archimedean tilings and in combination with the polyhedra, it results in nice animations again. So in this case, an Archimedean tiling, but when you look at it in another way, you will see that it's connected to the octahedra. The unfoldings of the octahedra just give the tiling of the Archimedean tiling. So there are a lot of new ways now with the works of Albert Dürer to handle the polyhedra. We now know many more complex polyhedra, and when we apply Dürer's ideas on this part, then we come to new things. Well, again, here a drawing of Leonardo da Vinci, the Stella Octata, the Kepler star, so to say. Well, this one can be unfolded with in the way that Dürer studied. It turns out to be a very simple unfolding that you get then. Just this strip can be used to make the Kepler star, as you can see. So Dürer's idea of connecting the 2D net and the 3D object is also in this case a very interesting things. It brought me to another idea, and in fact, also this was initiated by Dürer itself. When we concentrate on the nets, we can calculate. We can make calculations of polyhedra in a very different way. Before Dürer, it didn't make sense when you asked what is a tetrahedron added to another tetrahedron. But now with Dürer, we got other possibilities, because now we concentrate on the nets. And well, for this snub cube, we can already see that it brings us very new ideas, because now is the Kepler star connected to the snub cube, and that's because we take parts of the snub cube and fold it in another way, and then we have another polyhedra which seems to be connected to the first one. So also when you start with just tetrahedra, then we can use the unfoldings of the tetrahedra in this way. So we unfold 5 of the 6, and we fold it again, and it results in the icosahedron. So what you do here is you say 5 tetrahedra is in fact an icosahedron. Or if you want to tell it another way, the icosahedron can be split up in just 5 tetrahedron.
Excuse me, Dr. Ruiz.
Yeah,
The time is over, so
I need
could you
2 more minutes, I
wrap up
think.
your presentation?
Can I use 2 more minutes?
Yeah, no problem.
Yeah, okay. Yeah, okay.
Thank you.
So this is now the calculation that you have. 5 tetrahedron becomes 1 icosahedron. And well, again, with 5 tetrahedron, you have also the icosahedron. And in fact, when we look at Dürer's drawings, we see very clear that he was thinking in this way about octahedrons, tetrahedrons, and icosahedrons. So you can combine it in any way. And this is in fact what Dürer himself also showed us. This was his net for the octahedron, and in fact, this is 2 nets of the tetrahedron. So an octahedron is a tetrahedron plus a tetrahedron, or 2 tetrahedron is together an octahedron. Another way of going on now is you can see the cubes not as solids but as covering of something else. So we can use the unfoldings of 2 cubes to make 1 bigger cube. And I'd just like to show a few more. So with 4 cubes, you can make 1 big cube, or even with 5. And this can be done with the other solids as well. So when we have 3 tetrahedrons, we can unfold it and fold it again to a tetrahedron which is bigger. Well, I think I stop it here. I thank you for your attention, and well, okay, thank you.
Yeah, thank you very much for your interesting presentation. Please give to big hands. Yeah, thank you very much. And also you prepared the video clip. It's very interesting. And so your video clip is help us understand the mathematics and especially geometry. Thank you. And we will take a time for question and comments after second lecture, keynote lecture. So is it okay?
Yeah.
Yeah,
okay.
thank you very much. And I will introduce the next speakers. Yeah, it is my great pleasure to introduce the Professor Jong-Mei Jiang at Yamaguchi University, Japan, who is going to speak to us on a subject, trial and practice on open innovation education with the interdisciplinary student cohorts. Maybe in 2010, he started the Open Innovation Practical Education programs in order to promote international interdisciplinary education. He started the Creative Engineering Design competition from 2011 and established the summer program for innovative engineering design, mainly for university students from Japan, China, and Korea, maybe from 2013. Okay, let's we give two big hands. Welcome to Professor Jiang Zhongwei. Are you ready?
Okay, thank you, Professor Mihei King. Let me share my screen. Oh, can you see the screen? I very appreciate ICAS giving me the chance to introduce our experience on innovation education. And, okay, today I will give a talk in 4 parts. The monotsukuri education. Monotsukuri is a Japanese word, which means the creative design and manufacturing. And this word is maybe, as I remember, coming from the 1990 in Japan. So they started this kind of program very early. First, I'd like to introduce this kind of training program in our Yamauchi University, both for the undergraduate students and the graduate students. Based on this experience, we established the SPEED, the summer program for innovative engineering design, also the CDC, the International Creative Engineering Design competition. Finally, as summary, I'd like to express some opinions and comments based on my experience. So first, I would like to first introduce the curriculum for mechanical engineering at Yamauchi University, because I'm a professor in mechanical engineering department. In our curriculum, for the first year students, they are mainly the liberal arts subjects. In the second and the third is the subjects related to mechanics. Here we have very important subjects we call the monotsukuri, the creative design and manufacturing, both in second grade and the third grade. Today, I want to mainly introduce these 2 programs. In 4th grade, we have a research subject. Usually the research topics is given by their supervisor. The topics is something very specialized and much narrow. But this program is also very important to training the students to know the whole process in research, also learning some specialized skills. So first, I'd like to introduce the 1st grade monotsukuri training program. The objective of the 2nd grade program is to learn some basic skills by solving a given problem. The materials provided is a robot kit, including the microcomputer, motor, distance sensor, and some other sensors. The task is designing and prototyping and analyzing mechanics. Here's one example. The students at this year, it's required development a tactile sensor, and it can detect the weight of the object like this in the cup, and then move this cup to a right place. So they have to design the sensors. And I like to show one video clip. Let's move on. Oh, it's not work. I'm sorry, it's not work. So, yeah, test before it's working. I don't know why. Okay, I just skip this one. And in that case, they designed the sensors by themselves. They using one spring and several electrodes, because when the weight difference, it will be makes a change in length of the spring. So they detect the length and know how weight it is. It did very well and a very interesting video, but it doesn't move now. Okay, and next is the third grade monotsukuri. This one is upgraded from the second one. The objective is cultivate the problem discovery and the problem solving. The students are required to design a mechatronic system proposed by themselves in order to solve some social problems. Here shows the two examples. This is last year's students' work. Because the COVID-19, they have many problems. So one student or one teams, they make a mask that can show the facial expressions during talking. Because in the COVID-19, you cannot see each face. So they make this kind of device. Another one, the development of one device that can change the room fragrance according to the mood and the scenes, such as during the study, or sleeping, or relaxing. So they set up the fragrance in different places and rotating this disk, and then they can get different fragrance. It's also a very interesting project. They're thinking by themselves. So for the undergraduate students, we also found some limitations or problems. First of all, the team members are in the same major. So it is very difficult to obtain divergent thinking. So the idea cannot become very widely. And another is a limitation of their skills and the knowledge, because they are undergraduate students. So when they consider idea, also the problems extraction, even the solving method, sometimes it will be very easy to restrict it. Another issue is the difficult to cooperate with other departments because of the difference in curriculums, also the difference in timetable of subject. This is a very difficult problems to solve. We tried many ways, but it's really difficult. So we get one solution, is create a new grade 8 course program. And just in 29, it was a time where there was a serious shortage of the embedded engineers. So we created an embedded system technology education program for master course. So students from grade school, mechanic, electric, and the computer information, they can join this program. Because in the master course, the curriculum is much flexible and easy to adjusting with each other. Further, in the 2016, due to the needs of cultivation of IoT and AI engineers, we upgraded the embedded program to the mechatronics and IoT. In this program, we try to invite the students from the humanities faculties, also the medical department, to join the team together. Also, during these trials, we also established the CDC in 2011 and also SPEED in 2013. It is a kind of international programs. I will be introduced in 10. Okay, this is a detail of the math course program for mechatronics and IoT. In these curriculums, we divided the two parts. One is a research parts and another is education parts. In research parts, they have the math course. It is totally, we will have 6 credits. Today, I want to introduce the main education parts. Education parts, the main one is the also sophisticated monoscopy. It's a 1 year's project. It have the 4 credits. To support this one, we also have the speed training program and also some special lecture on industry design and the problem solving method. Also, we have some subjects on the management and the finance and intellectual properties. The total credits will be 34 if the students want to get the certificate of this course. The main part is the sophisticated monoscopy program. These programs, we divided into 4 quarters, 2 semesters. In the first quarters, each student first presents their graduation research contents and the skills they were acquired, so the students can understand each other. And then we make the teams. So after that, they survey the social problems, create ideas and the concept. In here, we give some lectures on concept illustration methods. Because they are coming from different department, so if you just using the words, it's difficult to understand and also get the image. So we ask them to make some image graph and something like that. So they need some technique. In the second court, they have to brush up their idea and the concept, and then design and create the model draft. So in this case, we also give some skill training on 3D design and the prototyping. And during summer vacation, we invited the experts to give the intensive lectures and the exercise on fundamental industry design, because we do not have this kind of lecture in our engineering faculty, and also problem solving problems. We also encourage students to participate in the SPEED program to have the experience of creative activities by international teamwork. In the second semester, the third quarters, they refine the design and manufacture the products, and they have to present and demonstrate results at the CDC. And also at this one, the idea almost fixed. We also recruit the students from the other faculties. So for the fourth quarter, after CDC, they have to refine their products and brush up the presentation materials again. We also invite experts to give the lecture on the basic presentation skills. Also, the expert will guide how to improve their presentation in detail by showing the specific examples in their previous presentations. After that they will be given the final presentation to the persons who are inside and outside the university. This is make the course class scenes, teamwork, brainstormings, discussion, and list the products. It's more, maybe I remember maybe almost 10 years ago, they considering the virtual tactile device for online shopping. So if you touch that, you can get the sense of the products. This is the post for the final presentation. They translate English to Japanese again, and you can see it's modified very beautifully. And this example is the students, they cooperate with the humanities students. And this one, they cooperate with the art department students in a Chinese university. So it's not moved. Oh, I'm sorry. Okay, and then based on the experience, and also in order to respond to global change in education, we developed the summer program for innovation engineering design with speed. This is a very exciting program. Students mainly from China, Korea, and Japan. The first speed is held in 2013 in Japan, and it will be held intense for Japan, China. From 8th to 10th, due to the COVID-19, we continue this kind of activities online. We found that online is also fairly efficient for students to do this kind of creative things. This is one examples of the programs of this year. This is online programs, and usually we take 1 week or 10 days. Usually we have the brainstormings and the teamworks. The students have to give 3 presentations, first, second, and final. They will brush up their ideas and then make products quite well. This is some pictures. Shows the opening lecture and skill training. And this one is brainstorming and teamwork. Final is the presentation and the demonstration. Also, they have some performance and events. Next, I want to introduce a CDC, Creative Engineering Design. This one is started from 2011. At the beginning, it is designed to be a kind of platform for education evaluation, because we do not have this kind of international evaluation systems. This one is also doing in 10 for 3 countries. From 10th to 12th, it's online, and it also works very well. And this is a kind of programs for CDC. And this is an online case, like we today doing the online. It's also very interesting and efficient. This is the post examples. You can see they designed very well. And this one is some pictures. The students in CDC, they have first to give 5 minutes oral presentations. After that, the students have to go to their booth to demonstrate their products, and our review will be reviewed. During reviewing, students also, they have their friendship activities. This is a kind of team-based games. In the closing ceremony, students will be given some performance. It's really exciting.
Professor Zhang, I'm sorry to interrupt. Would it be fine if I ask you to wrap it up within some minutes? I'm sorry,
yes.
because we are running out of time.
I will be 1 minute left. Okay.
Okay.
Soon. Okay. Finally, as a summary, I want to give my opinions. Okay, first for low-grade undergraduate students, it might be better to set a goal for acquiring the basic skill. And the topics maybe is simple, clear as possible. For the upgrade of undergraduate students, maybe we can guide them to incorporate with story making. It is also very important to widen their thinkings. And for master course, they already have the skills and the knowledges. So the place we have to emphasize them to exploring social problems and creative stories. It's very important. Actual speed, as I experienced, is one wonderful program for STEAM educations. Many professors also said you can see the great view of the growth of the students like a bamboo shoots after rain during speed. Finally, I like to express my sincere thanks to all the team members. They did a very great effort and contributions to CDC and the speed. Thank you very much, Professor Kim.
Thank you so much for your inspiring presentation. Since Professor Lee Kim is out of the conference room now, I'm taking the mic. Thank you so much for the presentation, Dr. Roloff and Professor Zhang. Now we have some minutes for Q&A. If you have any questions for Professor Zhang and Dr. Roloff, please raise your questions. Please don't forget to have your mic on and give your question. While you become ready for your question, why don't I ask Professor Zhang and Dr. Roloff to give us their suggestions for those of us who are interested in STEAM education and for the future of STEAM education. Professor Zhang?
Okay. Yeah, for STEAM education, I think it's very, very important. But actually, if we want to combine the students from science, engineering, and art, humanities, and some other case, it's really hard for the students to cooperate with each others. So our professors have to support them. Also, we need a kind of system from the university to support them. And in my experience, I tried this kind of things in our university. I still find it's very, very difficult. So we extend our education international. We find it will be much easier because from different universities, they have different flexibility. So we can combine each other. It will be the very easy way to do STEAM educations. So the SPEED program maybe is a very good program. And also next year, the SPEED program will be held in India University. If you have interest, I hope you can attend that and you can see how fantastic it is. Thank you very much.
Thank you so much for your comment. Dr. Roloff, would you share your insights on STEAM education for us?
Yes. Well, there's an A in STEAM, and I think that's very important. It's added as the last part of STEAM. It used to start as STEM, and now it's STEAM, happily. I think it's very important to have knowledge about how artists think about technology and mathematics, and artists normally try to express things in a visual way, and that can help other people as well as when we want to understand more things. So I think the A in theme is very important.
Thank you so much for your opinion. I believe the keynote speakers' inspiring ideas and insights have provided a firm ground on which additional valuable ideas will be built up during this conference and stretched toward the advancement of STEAM education. Now it's time to wrap up this keynote session and move on to next part of the conference. We have oral presentation sessions live and a recorded presentation session and a post session as well. Please refer to the conference schedule, which is on pages 33 to 35 of the proceedings booklet and file. There are 2 live presentation sessions, which have 2 sub-sessions respectively. If you are interested in live session 1, please stay here in this Zoom conference room. If you'd like to attend the session 2 live presentation, then please check the ID number and the password for the session so that you can enter the Zoom session on time. Let me just tell you the number for you. In case you'd like to move to session 2 of the live oral presentation, the session ID is 615-621-1648, and the password is 3641. Please feel free to take a short break, and it's just 3 minutes, I'm sorry. And we will see you in the next sessions at 5:10 p.m. Korean time, which is 10 a.m. Central European time. See you there very soon. Thank you.
Thank you very much.